Yeah, good morning, everyone. First of all, well, I'm Gerardo Santillan. I'm a senior specialist from Semantum. First of all, very happy and thank you to the Finnish Automation Society for letting us present this here today. Today we will be showing these projects and some results of this work, where we are applying simulation aided methods for testing the control application of these cruise ship LNG systems. And today I'm joined by Markus Lehtopohja from Meyer, Turku.
Hello to everybody.
All right, hello. Okay, Markus, would you like to start first with that?
Yes. So here is we have been a collaboration project with Semantum, and here is some gathered topics from Meyer Turku shipyard. So we are a very old shipyard. Of course, Turku shipyard has been many names during past years, and at the moment we are at Meyer, and we have two other shipyards, one in the Neptune and the one in the Papenburg. Both are in Germany. And our main products are these cruise ships and car ferries and special type vessels such as icebreakers and these kind of vessels. Yeah, at the moment I think we have roughly 1,300 between 1,400 people. And what has been leading us here and today is this, that our main stream is always developing items and conceptual solution and designs with our customers and also with our system suppliers. And mainly that is the reason why I am here today with Semantum.
Right, Markus, thank you. Just some words related to our company. So that was Meyer Turku. Now, some things related to Semantum. We are a software development company. We are from Espoo. We have been around since 2007. In Semantum, we have a multidisciplinary teams of software developers, automation experts, and also modeling and simulation specialists. And we are doing different solutions for process industry, mostly based on modeling and simulation, but we also do engineering automation solutions, and we also do life cycle assessment solution. Yeah, so some things about the actual project and what are the motivations for this project to happen. To begin with, I would like to start by introducing, maybe it's not familiar to all of you, what is this LNG? LNG stands for liquefied natural gas. What happens is that the natural gas is liquefied by cooling it to roughly minus 160 degrees, and then its volume is reduced by roughly 600 times so that it can be stored and it can be transported easier. Recently, there has been a lot of hype about LNG, and LNG has been recently used more as a marine fuel because it has less emissions than other fuels. Important to say that Meyer Turku is currently building different ships based on LNG. And of course, this brings different challenges, as Markus will also tell. Like, for example, increased on the capital expenses, so it's more expensive to build these ships. And then Meyer Turku is mainly building cruise ships. So, of course, in the cruise ship industry, there are tighter regulations when it comes to safety of the passengers. And because of this, there's also a need to train operators and crew members so that they can operate these LNG fuel systems efficiently and also safely. But Markus, would you like to tell us more? What are the motivations for this project?
Yes, thank you, Gerardo. So I have gathered few bullet points. What are our motivations and a little bit about the project. So where we have now done this testing with Semantum is a big cruise ship, and it will deliver it with new type of LNG system. The LNG system is not the same what we have delivered for previous vessels, which has been left lately. So that is the one key item. Then one important key item was also that the owner has request hill testing with the ship contract, and that was the main driver when we started this whole project. And during when we done this project, we noticed that the hill testing is too extensive way to do. So we changed the testing method to mill and sill, and we agreed this with the owner. And on owner side, there was a driver that this is the first ship to owner where they have LNG system. So they also want to ensure that everything is like tuned and no big issues. So, and then there is a customer and our need that we want to avoid issues during our commissioning period. And of course, owner want to avoid issues during operation. So when we have in a commission period, there happens a lot, and then we test very lot of different things, and we tune the system, and this mill and sill phase will help us to get the better controls and control loops in our system, inside our system automation. And when we have better tuned process, then we are much more better commissioning time, and then we save the money.
Great, thank you.
Yeah.
Yeah, so, sorry, Markus, continue.
No, then there is we get in the end we get the more mature system, and then of course we save money, and owner save money during operation. So yeah.
Right, thank you.
Those are the main drivers.
Yeah, thank you. So specifically in this project, what we are doing is we are using simulation-aided methods to test the control application of these LNG systems. The idea is to use a dynamic process simulation model to test either a control application model or the actual control application that will be commissioned and that will be controlling the real system. Depending on which application we are using, we can either do it on the simulation system where the same process simulation model is available, or we can do it then running the control application on a soft PLC or a DCS emulator or in the actual PLC. The main advantage, one of the main advantages of this is that this is done with a dynamic process simulation model based on first principles, so the testing can be done more rigorously, and the results of these tests are more close to what we would expect on the real system. Another advantage is that this can be done already during the design before the system is built, so that there's still time to do changes on the control application side, and also there's time also to verify the design of the process simulation model. Specifically, Semantum has been helping Meyer for some years already to use simulation, and Meyer Turku is using simulation for different processes, like for example this mill testing, but also for example for testing energy systems and optimizing them. But in this case, in the specific project, what we are doing, we are testing this control application using a mill configuration and a sill configuration. Here on the figure, you can see what are the differences. In the mill, we are running the entire testing using the simulation system because we are using a control application model and a process simulation model. And then once we are sure that this control application model is working correctly and that we have an updated process simulation model according to the latest specifications that were used to build a ship, then we can go to the seal where we are testing the actual control application. The purpose of this, again, is to verify process design, is to analyze the system behavior of the control application, but also of the process, to test, for example, stabilizing control loops, to test different operation sequences, to test the interlocking of the control application, and basically verify safety functions of the entire control system. Well, now some technical parts of the project itself. We are using APROS dynamic simulation tool. APROS is a dynamic tool that is developed by Fortune and VTT. Semantum is also helping them to develop this tool. It has been used for power generation processes, but it's also capable of simulating these LNG systems, and that's why we are using it. Specifically, this marine LNG fuel system, well, how it works, basically, the LNG is bunkered into different tanks. In this case, for example, we have 2 tanks. Then the LNG that is stored here is stored in low pressure tanks, and sometimes there are heat leakages. Therefore, there is a boil off of gas sometimes in the tanks. And this boil of gas needs to be processed so that it can be used as a fuel later also. But then the LNG then can be pumped and then vaporized so that is provided to the fuel users. It is vaporized using heat exchangers that utilize a combination of water glycol mixture there so that it can give heat, and then this liquid is converted into gas. And then important to say that in these cruise ships, it's important to have this cold recovery from the LNG so that the energy that the HVAC systems are requiring to cool the ship is reduced. So it's possible to utilize this cold that we get from the LNG. So you can imagine this system is quite complex. And on top of that, as you can see here on the diagram, everything, there's redundancy in the system. So every equipment there are 2 of each equipment, so that we reduce the amount of time, that we increase the robustness of the system mainly. And that makes the control application quite complex. When it comes to the simulation model was developed by a third party, but during this project, we have been updating it and refining it so that it corresponds to the latest, to the system as built. And the simulation model is a comprehensive model that includes the entire fuel gas system with all the subsystems, including the water glycol system, and it also has a control application. So finally, something related to OPC UA. This is the architecture that we are using to test this. We have on the one side the simulation system, on the other side the control system. On the simulation system, we have the fuel system process model. We have the control application model that we are using during MIL. And we also have the testing manager. Testing manager is an extra piece of software that is used to configure tests in a systematic manner so that we configure the test as a series of sequences. And later, when we want to repeat the test after changing parts of the control application or the simulation model, we can just ask this testing manager to run the same tests again. On the control system, this control application was developed using PCS7, and then CMIT is used to grab this control application, and the OPC UA server of CMIT is used to expose all the other space of the control application. On the simulation system, we have an OPC UA client. So we are using OPC UA to connect all the process variables and the control variables, but then we have to use another protocol or another communication mechanism to handle the synchronization between the simulation system and the control system. Later, we have some conclusions related to this that are interesting. The MIL configuration is all done. All this MIL testing is all done on the simulation system. There's no OPC here. But we do this because it's important to verify the design of the system, and we do this because it's a preliminary test towards SEAL. Because in SEAL, what we are trying to do is to actually test the control application and to make sure that all the safety functions, all the control loops, all the interlocking is working as intended. So in this seal configuration, again, we are using OPC UA to communicate all the process and control variables, but still we are using something that is called remote control interface as a communication mechanism to synchronize the execution of the simulation system and the control application. One thing that, well, there are roughly in this project, there are roughly over 200 tags, more close to 300 tags that are exchanging information there. One thing to say here is that we need to use this RCI, this additional communication mechanism, because OPC does not have any way, any method available for us to do that. But we do believe that it's something that OPC could handle also, so that we don't need this extra communication interface to handle all the synchronizations. Some conclusions about this project. So mill testing results, we have been doing roughly 20 tests. I think we can agree that together with Meyer Turku that Semantum as a service provider, Meyer Turku as the shipbuilder, and then the customer, the owner of the ship, we have all gained a lot of insight about this LNG system and how it's working. And we are sure now that certain parts of the design are working as intended. And there were some changes made after the results that we got from mill. And then on the seal phase, the seal phase is currently undergoing. So the same test that we configure in mill will be then run on a seal environment. And then the only difference is that instead of making sure that the design of the LNG system is correct, we are now focusing only on the control application. And that will be the main emphasis of this phase. For this, we have built different tools in Semantum to support these activities. One of the main things that we did, we developed a simulation manager to synchronize execution of simulation and control systems. This could have been done using this OPC UA, but we are using this extra communication mechanism. Related to OPC UA, the conclusions that we have is that OPC UA can successfully be used for this. But again, we still need to handle this synchronization using an external communication mechanism. And we are wondering if it would be possible for OPC UA to also have some type of additional specifications to handle this. So for example, it would be good if OPC UA could have methods for starting or stopping the simulation, or for saving or loading initial conditions. And this would be useful not only for this testing of control applications, but for any application that requires connecting a simulation system with an OPC UA server. So for example, or with a control application. For example, in training simulation systems, or also for developing these digital twins based on simulation for operation support. Markus, would you like to give some final conclusions from the Meyer Turku side?
Yes. So thank you, Gerardo. So yeah, what I have seen now, what we have done is with the mill phase, I'm very, very happy for the results and findings what we have done. And we have also been able to tune our system and make some corrections to our automation software. And from owner side, I spoke a little bit with their words. They are also seeing the benefits of this. Future is still a little bit open, but what I see, I personally would like to extend OPC UA connections more wider in the ship, because I see this the ship is quite good platform to use OPC UA between different systems.
Thank you, Markus. Thank you, everyone. In case you have any question, please feel free to contact us today on the Gather Down, or you can send us a mail. Thank you very much.
Thank you.
Thank you, Markus and Gerardo.